Hello, welcome. This question has been on the Facebook timeline for some time. We have interesting answers that are correct, but people are still asking how the answers were derived. We got three. So now this can be solved in three different ways by using the factorization, polynomial division, or the L'Hopital's rule. Let's see if we can be to do all the methods. Now in factorization, I am going to have this as. Remember, when we substitute directly the 1 into the place of x, we are going to have 0 divided by 0, which is indeterminate. To become the limit of x cubed, 1 cubed, x minus 1, at this is approaching 1. We know 1 cube still remain what? 1. So that gives us a difference of a cube. And for a difference of a cube, we know the limit become the first number minus the second number into bracket, the first number square plus the product of the two numbers, 1 times x, that will be x, plus the square of the last number, that will be 1. So that will be divided by our denominator, x minus 1. Still, x is approaching 1. I think I've discussed this in one of my videos in the playlist. You can check that. Not the limit, but the difference of a cube and the sum of a cube and algebra. So here we can see a common factor will cancel out. So our limit will just be x squared plus x plus 1, where x is approaching what? 1. So we now substitute the value of x, meaning I'll be having 1 squared plus 1. Wherever I see x, I put 1. So 1 squared plus 1 plus this original 1 here. Then that will be giving us 3. This will be 3. Therefore, the limit of x to the power 3 minus 1, x minus 1, as x is approaching 1, is nothing but what? 3. And I'm sure with this video, you'll be able to get a concept how we get the 3. The next one, I'll take the polynomial division, then the L'Hopital's rule. Thanks for watching. Bye-bye.